Hello everyone. In this video, I will to provide a preview of the product that was carried out with the intention of constructing an underwater software robot. And this work consists of an introduction, theoretical background, proposed methodology, tests, conclusion, and future works. Okay, so the motivation for this research area was driven by the potential application of maritime robots for inspecting structure, especially in underwater operations within the offshore industry, creating the perfect scenario for the development of national alternative capable of operating similarly. Additionally, it can be used in biological research to film and study marine life behavior without disturbing the ecosystem. Uh, the objective of this project is build a robot with flexible material, make this robot capable of working underwater, and control this robot from outside the water wirelessly. Okay. Uh, in order to support this thesis work, scientific refer reference reference within the field of software robotics were sought to develop an appropriate research framework for the topic. So, first I will discuss the choice of microcontroller. At the beginning, we considered adopting ARM because it is much more powerful in process, but we wanted to keep a simple product, and Arduino, despite its simplicity, is a versatile microcontroller that allows us to carry out various projects. For our application, Arduino would be sufficient. Since the system includes two hydraulic pumps, we require a device to control these pumps. It is small, runs at the designed working voltage, and meets the working current requirement of pump. So we chose this H-bridge L298N. So this is the peripherals, uh, the servo motor, waterproof, module joystick 3-axis, and the submersible pump. To communication network, uh, we had two options in mind, LoRa and XB, but XB had some communication problems during the initial test, and LoRa presented more stability for our application. LoRa, which stands for long range, is a low power, long range wireless communication technology designed for IoT and M2M, machine to machine applications. It enables device to communicate over long distance while conserving battery power, making it suitable for various IoT and remote monitoring applications. LoRa device in your pinout. And the proposed methodology, the concept, the activities carried out during the project were divided into main stages to be executed. Detail in modeling, embedded electronics, like a pump, valves, and microcontroller, and the step tests, strain tests, tests of the control and transmission tests. The structure was divided into two parts and designed in software, as shown in the figure. The electronics of the fish were configured as follows, with one Arduino, two submersible pumps, one LoRa receiver, two servo motors, and one LiPo battery. and on the right, the control electronics consists of one joystick, module joystick, push buttons, LoRa transmitter, and one LiPo battery. So it is the program logic. Basically, we defined the LoRa variables and the actuators variables, and then built the conditions using if-else statements. This is the first design of the tail in your strain test. The first communication test between devices. And here is your code. On the left, the transmitter code. On the right, the receiver code. This is the final structure of the fish. And this is the video of the tail test result. Results and discussions, project costs. So the costs associated with electronics construction on the left, and on the right, costs associated with structural construction. And the conclusion is the main objective of this research work was the development of a low-cost system based on soft underwater robot to be applied in underwater inspection process to resemble a fish, not posing a threat from the perspective of aquatic animals. And it is important to highlight the various challenges faced during the implementation of this system. Firstly, as it is an underwater robot, it was necessary to develop a housing design that could prevent water from entering the developed electronic components. Another significant challenge of the project was the development of a feasible electronic system for the activation and control of the tail. And future works. In order to improve the product, we should consider enhancing the waterproofing system to ensure better protection of the electronics, developing electronics with smaller components to make the system more compact and efficient, developing a navigation code that enables both autonomous and semi-autonomous operation of the robot. This means the robot should be capable of continuing its mission even if communication with the operator is lost. Equipping the robot with sensors designed for inspection purposes, such as sonar, cameras, and other relevant sensors. And the final, improving the communication system to resemble the TMS, Tether Management System, used in remotely operated vehicle. So currently, an ROV primarily communicates using an umbilical cable, a TMS, the Tether Management System, and then the tether. The TMS in this case helps maintain stability in the ROV's navigation, making it a safer system. My proposal is to create a similar TMS system, but this TMS would only be used to send commands to the fish in similar environment, water to water, thus improving signal quality and potential, allowing for greater communication distance. Because our biggest challenge in this project is to implement a wireless communication where the controller is out of the water while the robot is in the water, and we know that in air radio frequency system works better than in water, while sound waves work best in water. So maybe this could be a solution to realize this idea. Thank you, everyone, and bye bye.